Hey everyone. Today I'm going to use a sample problem to go over the different units of concentration you may see when it comes to solutions. So this question, we have a sulfuric acid solution containing 571.6 grams of sulfuric acid per liter of solution, and it has a density of 1.328 grams per centimeter cubed. So we have to calculate here mass percentage, mole fraction, molality, and molarity. These are all four common ways to express concentration. So A here will go with the mass percentage. So to do this, I'm just going to assume we have 1 liter because it says we have 571.6 grams of sulfuric acid per liter, and it gives the density as well. So I'm just going to say we have 1 liter. I can choose any volume I want, but 1 is the simplest. So 571.6 grams of H2SO4 per liter times 1 liter, and I have 571.6 grams of sulfuric acid. Now, I have to figure out what the total mass is, and then I can get the mass of water once I have total mass and the mass of sulfuric acid. That looks a little bit like a 3, so I'm going to make sure that's clear as a 5. Okay, so total mass, I was given the density, right? The density is 1.328 grams per centimeter cubed. 1 centimeter cubed is the same as 1 milliliter. And then I have 1,000 milliliters in 1 liter. And I said the volume of this was 1 liter total. So this will give me my total mass. And it ends up being 1,328 grams. So that means the mass percent of sulfuric acid is going to equal 571.6 grams over the total mass of 1,328 grams multiplied by 100. And that gives me 43.0%. Now what we can do quickly in case we need to do it later on is figure out what the mass of the water is. So the mass of the water is just equal to the total mass minus the mass of the sulfuric acid. And this will give us 756.4 grams of water. So that's the first step. Step 2, the mole fraction, which is indicated with that. So that's the mole fraction of sulfuric acid. So I have to calculate the moles of sulfuric acid and then the total moles. So the moles of sulfuric acid, we have 571.6 grams. And the molar mass is 98 grams per mole. So this gives me 5.83 moles of sulfuric acid. Now to get the total number of moles, I need to know the moles of the water as well, because then I add the moles of water plus the moles of sulfuric acid to give me total moles. So we calculated last time 756.4 grams of water. Molar mass is only 18 grams per mole. And that gives 42.1 moles of water. So then the mole fraction of sulfuric acid is going to equal 5.83 over the total moles, which is going to be 42.1 plus 5.83. And this gives a mole fraction of 0.122. So notice, mass percent was 43%, but the mole percentage, or mole fraction, is only 0.122. So that shows different units of concentration, even though it's indicating the same thing, concentration, can be very different. Mass percentage versus mole fraction. Okay, number 3 now, or C, is going to be the molality. So molality is expressed as moles of solute per kilogram of solvent. Now the reason molality is used is that it's independent of temperature. Right? Pressure and volume, they change when pressure changes or when temperature changes. But mass does not change with changes in temperature. So by expressing this only in terms of masses and moles, molality will not differ depending on what temperature you're at. So we have our moles of solute. We know it's 5.83 moles of H2SO4. Divide that by our kilograms of solvent. It's going to be 0.7564 kilograms of water. Right, 756.4 grams, so 0.7564 kilograms. And this will give 7.70 molal. So molality is expressed with a lowercase m. We'll see molarity next is expressed with an uppercase m. Now the other difference between molality and molarity is that molality, it's only kilograms of solvent. Molarity, it'll be the volume of the entire solution. So the volume of both the sulfuric acid and the water for molarity. So D, we got molarity, and this is moles of solute over the volume of solution, specifically in liters. So we have 5.83 moles of H2SO4 over 1 liter of solution to give 5.83 molar H2SO4. So those are the most common units you'll see in concentration. And with just this one problem, I went through and showed each of the different ways to calculate these units.